Hello everyone, my name is Abhishek and I'm mathematics faculty here at askIITians. And the chapter that we are doing is mensuration, and this is lecture number 4 of this particular chapter. And before we delve into the topics that we are planning to cover in today's session, it's very important for us to revisit the weightage of this particular chapter both for your school examination as well as Olympiad examination. So if I talk about school examination, then in school examination, you can expect questions of around 11 marks from this particular chapter. What does that mean? That means around 3 to 4 questions can be expected from this particular chapter in your school examination. On the other hand, if I talk about Olympiad examination, then in Olympiad examination, around 3 to 4 questions can be expected from this particular chapter. Overall, if I have to tell you whether this chapter is important or not, this chapter is very, very important. Why? Because we will be using, or we will be coming across this particular chapter in 9th standard as well as in 10th standard. And also all the things that we are going to cover in today's session, or that we covered earlier, or that we will be covering in upcoming sessions, will be used again in 9th standard and 10th standard. And apart from that, the weightage of this chapter is very, very high. If you talk about school and Olympiad examination both, that makes this particular chapter super important. So be very attentive while we cover this particular chapter, and ask me in case you have any query or any doubt when we cover any topic. All right. So these are the topics that we are going to cover in today's session. First, we are going to discuss the surface area of cone. Then we will be discussing what is the meaning of surface area of hemisphere. Thereafter, we will be discussing the surface area of a sphere. Apart from that, we will be discussing the volume of cone, we will be discussing volume of hemisphere, and we will be discussing volume of a sphere. If you remember, in the last class, we'll discuss the surface area and the volume of cube, cuboid, as well as cylinder, right? We also did problems based on those 3 topics. Here as well, we will be discussing surface area of cone, hemisphere, and sphere. Apart from discussing the concept and the formulas, we will be doing the problems based on these 3 concepts. So ask me wherever you feel you haven't understood while I explain the problems as well as the concept. All right. So the very first topic we have is surface area of cone, hemisphere, and sphere. Okay. We already understood, or we already discussed in detail what is the meaning of the surface area. We discussed in detail what is the meaning of the volume as well. Okay. But let us quickly revisit those definitions or the meaning that we discussed. What does it say? The space occupied by a 2-dimensional flat surface is called area. It is measured in a square unit. We all know that, right? The area which is occupied by a 3-dimensional object by its outer surface is called surface area, and it is also measured in square units. Okay, what does that mean? That means if you look at your very first figure, that means I'm talking about cone. Then this cone that you have, if you have, let's say, cone, you can take, for example, ice cream cone, or you can take, for example, the birthday cap that we use in birthdays. If you consider those objects, you will see that if you are talking about, let's say, the birthday cap, this is your birthday cap. All right, let's say. Then what happens is this birthday cap, what is the area which is occupied? The area which is occupied by this birthday cap is this curved part. Okay. This curved path, the area which is occupied by this curved path, we call this as CSA. CSA stands for curved surface area. Understood? And apart from that, what happens? There is a circular base as well here, if you pay attention. Okay. There is a circular base here as well. So that circular base also covers some area. Okay. And we all know what is the formula for the area of a circle. So if you are talking about, let's say, there are 2 types of areas that we are going to consider as far as cone is concerned. The very first is going to be the curved surface area. What is the meaning of curved surface area? Curved surface area means we are talking about this part, guys. Okay, this is your CSA. Okay, means the area which is bounded, or the area that is covered by the curved path of this cone which is provided to you is called curved surface area. And when we say the total surface area, this TSA here, it stands for total surface area. So when we say total surface area, that means we are talking about the curved surface area as well as the area of the base. Okay, because when you are saying total surface area, then in total surface area that curved path is included, and apart from the curved path you have that area of the circular base as well. When you add the area of the curved path and the area of the circular base, you get that TSA, or what you call as total surface area. So if you talk about curved surface area of this cone which is given to you, the curved surface area of cone is given by pi RL. Okay, pi, we all know what is that, that's 22/7, and if it is specifically mentioned that you have to use 3.14, then go with 3.14. What does R here stands for? This R here represents the radius of circular base that you have. Okay, this represents radius of base. What does this L represents? This L represents slant height. Okay, slant height. And if you talk about this H represents height, the normal height or the perpendicular height basically. Okay, and there is a relation we have between these three. Let me show you the relation as well. I will mention here, 1 second. Okay, if I consider this triangle, let's say I am going to call it A, I'm going to call this as B and this as C. Then if you observe this ABC, this ABC is actually a right triangle, right or not? And we know that whenever we are talking about right triangle, the Pythagoras theorem is very easily applicable. So if you consider this triangle that you have ABC, then in triangle ABC, if you use Pythagoras theorem, you can say that AC square will be equals to AB square plus BC square, right? By Pythagoras theorem, right? And if you substitute the value, what will you get? AC is given by this slant height, which is represented by L. So you are going to get L square. That will be equals to AB square, which is H. So that will be H square, BC square, which is R. So that will be R square. So that means the relation between the slant height, which is represented by L, the perpendicular height that you have, which is represented by H, and the radius of the base that you have, that is represented by R, is given by L square is equal to R, H square plus R square. And how this relation is beneficial? This relation is very beneficial in case, let's say, you are provided any two values. For example, they give you the value of R, which is the radius of the base. They give you the value of the height, that is H, and they ask you find out the curved surface area. Then you know, as far as the curved surface area of this cone is concerned, you need the value of slant height, which is represented by L. So you can easily find out slant height by using this relation, that L square will be equal to H square plus R square. You substitute the value of R, you substitute the value of H, you solve this relation, you will get the value of slant height, that is L. And if you can find slant height, you can easily find out the curved surface area of the given cone. So this relation is very helpful when you are provided any two values and you have to calculate the third value. We will see the application in the upcoming slides. So this is first for cone. And if you talk about the total surface area, I told you total surface area means we are talking about CSA plus area of base. Okay, area of base. So what is the value of CSA? CSA is pi RL, we all know. Okay, base is circular in nature, so that will be pi R square. If you take pi R common, what will you get? You will get pi R L plus R, and that's exactly what has been written here. So overall, let us quickly discuss what. Let us quickly revisit the two formulas that we discussed. First is CSA. We understood what is the meaning of CSA. The area which is covered by the curved path of this cone is called CSA. And the formula for CSA as far as cone is concerned is given by pi RL, where R is the radius of circular base, L represents slant height. And there is a relation between slant height, radius, and the height, that is L square is equal to H square plus R square, which is you can say, which is a result of Pythagoras theorem. And apart from that, we also discussed TSA, which is nothing but area, the area of the base and the curved surface area. That's it. Now, what do we have? If you talk about this hemisphere, okay, then in hemisphere, This curved path, this is your curved path that you have. This is your curved path. Okay. So the area of the curved surface area of hemisphere is given by 2 pi r square s, 2 pi r square, sorry. And if you talk about the total surface area, then in hemisphere, what happens is, as far as total surface area is concerned, so you will be having CSA plus area of circular top or base, whatever. Area of circular top slash base, whatever. Okay. It depends on how that hemisphere has been placed. So if you talk about the CSA is given by 2 pi r square. And since this base that you have, it is circular in nature, so its area will be pi r square. So when 2 pi r square is added to pi r square, you get nothing but that's equal to 3 pi r square. And that's exactly what has been written here. Clear? So the meaning of CSA, I hope, is very clear to everyone. The meaning of TSA is very clear to everyone. And also the formulas for hemisphere is, I hope, clear to all. Now, if you talk about sphere, in sphere there is one exception. That exception is there is like no difference between TSA and CSA, right? If they ask you to find CSA, then the formula remains the same as the formula we are going to discuss for TSA. Okay, because when you are talking about a sphere, when I say sphere means I'm talking about shapes like we have the shape of cricket ball, football, or any kind of a ball that we have. That is the shape of a sphere. So in a sphere, there is no difference between TSA and CSA. That should be that should be very, very clear to you all. Okay. And if you talk about this value, CSA and TSA, that is given by 4 pi r square. Again, what is r? R is the radius of the sphere, which is under consideration. Why there is no difference between TSA and CSA? Because sphere means entire curve, means the area of the entire portion which you can touch of that particular sphere. Let's say you have taken a ball, cricket ball in your hand. So the entire portion of that ball which you can touch by your hand, we are talking about that area. And if you look at the cricket ball, then the curved area or the total area, that remains exactly same, because that entire portion of the cricket ball which you can touch is same for both TSA and CSA. So TSA and CSA, that remains exactly same as far as sphere is concerned, and that is given by 4 pi r square. Clear? So I hope it is very clear to everyone what is CSA, what is TSA in case of cone, in case of hemisphere, in case of a sphere, and also the meaning of the different symbols that we have used here. I hope that is also clear to all. And also I hope it's very clear to everyone, like what is is there any difference between TSA and CSA as far as sphere is concerned? And if there is no difference, why? And also what is the formula? Please go through it before we move to the application of the formulas that we discussed here. Is it done? All right. So now we have one problem. I would say this is a very important problem. Okay. Very important. What does it say? Read it. It says a hemispherical depression is cut. So this depression that you have here, this is the hemispherical depression. Okay. This is what they are talking about. Hemispherical depression. Clear? This is what they are talking about. Is cut from one face of a cubical wooden block. Okay. Such that the diameter L of the hemisphere is equal to the edge of the cube. Means whatever the diameter of the hemisphere that you have, which they have denoted by L. Let me show you that this diameter they are talking about. So this diameter is same as the length of the edge of this cube. They are asking you what is the surface area of the remaining solid. So let us understand what we have to calculate here. First thing, we have to calculate the surface area of the solid that will be left after removing this hemispherical depression whose diameter is equal to L, right? So after you remove this hemispherical depression, it is very clear that you cannot touch this circular part or this circular base that will be formed because of hemisphere. You cannot touch it. But at the same time, you can easily touch this part, which I'm going to highlight. You can easily touch this part, right or not? This hemispherical part, you can easily, right? So this hemispherical part that you have, you can easily touch after the removal of this hemispherical depression, correct? So if you keep this concept in mind, it should be very clear to you what we have to calculate. Let me show you. So if you have to find out the surface area, then the required surface area will be what? Required surface area, that will be what? That will be equals to TSA of this cube that you have. Okay, from that you need to subtract the area of the circular base of this hemisphere that you have. So minus area of circular base of hemisphere. Okay, and what needs to be done? To that you need to add the curved surface area of hemisphere, because you can touch that, right? So if you talk about the total surface area of a cube, we know the total surface area of a cube is always given by 6 into side square. Here the length of the side is equals to L unit. So that would be given by 6 into L square. Clear? If you talk about the circular base, then the circular base has got diameter equals to L unit. So what will be the area of this circular base? That will be pi. Radius will be L by 2. So pi L by 2 square. And if you talk about the curved surface area of hemisphere, we just discussed the curved surface area of hemisphere is given by 2 pi r square. So you are going to get 2 pi. What is r? R is going to be L by 2. Is that clear? So the TSA of cube, let me show that to you here. The TSA of the cube, the total surface area of the cube is given by 6 into side square. So side is L unit. The area of circular base of hemisphere is pi r square, because that is circular in nature, right? And the curved surface area of hemisphere, that is given by 2 pi r square, where r is the radius of the circular base, which is equal to L by 2 here. So you are going to get 2 pi L by 2 square. Clear? Now you can solve these last two terms first. So you will get 6L square. So 2 pi L by 2 whole square minus pi L by 2 whole square is going to give you pi L by 2 whole square. It's like 2x minus x situation. Okay, if I assume this value to be x, then this is nothing but 2x and this is x. So 2x minus x gives you x, and x is pi L by 2 whole square. Okay, let us simplify it more. We have 6L square plus, if you simplify it more, you will get 6L square plus pi L square by 4, because what we were having here, we were having pi into L by 2 whole square, and L by 2 whole square is L square by 4. That's what we have. Now what you can do is you can take LCM. If you take LCM is going to be 4. So here you are going to get 24 L square, and this is pi L square. What can be taken out common? You can take L square common. So you will be getting L square by 4, and in the bracket you will be left with pi plus 24. All right. So this is the value of the surface area of the remaining solid. If you want to simplify it more, you can certainly simplify it more by substituting the value of pi, but you have to be a little bit careful with the calculation part, and that is going to be a final answer. I hope the meaning of the surface area is pretty much clear to all, and also how we calculated it, that's also clear to everyone. You can go through it and you can ask me in case you have any doubt in this before we move to the next concept. Done? All right. So here they have given this solution for your reference, guys. Whenever you want to go through it, you can go through it. They have, because the greatest diameter is given to be L, so the radius is going to be L by 2. And surface area of the hemisphere, we are talking about curved surface area here, that is 2 pi r square. Okay, so they substituted, so you will get 2 pi L by 2 into L by 2. This is L actually. So you will be getting pi L square by 2. Okay, so base area of hemisphere, because that is circular in nature, so that will be pi L by 2 whole square, which is pi L square by 4. After that, they calculated the surface area of cube. So to surface area of cube, they added the curved surface area of hemisphere, and from that they subtracted the area of the circular base that we have of this hemisphere, and thereafter you just need to do the calculation part. If you do it correctly, like, I do not think you will not get the answer. All right, yeah. So now what do we have? We have the volume of cone. We are going to discuss about volume of hemisphere, and we are going to discuss about volume of sphere. Okay, now what does it say? It says the amount of space measured in cubic unit that an object or substance occupies is called volume. We all know what's the meaning of volume. Let's say you have a hollow cylinder, or you can say a hollow cone, or a hollow anything. Okay, so the amount of space that is there in that particular object which is under consideration, we call that space as the volume of that particular object under consideration. If you talk about ice cream cone that you have, okay, let's say this is the ice cream cone you have. Okay, so what is the volume of this ice cream cone? Let me highlight that. So this represents the volume of, one second, this represents the volume of this ice cream cone, correct or not? That is the amount of space that is there as far as that particular object is concerned. So that amount of space represents the volume of the object which is under consideration, and here the object that I have taken was this cone. Okay, so if you talk about cone, then the volume of cone is given by 1/3 pi r square h. What is r here? R is radius of base that you have, radius of circular base. Okay, what is h here? H is height. H is height of cone. H is height of cone. And what is L here? L represents slant height. L represents slant height. Clear? On the other hand, if you talk about the volume of a sphere, when we say volume of a sphere, you can always consider like a football or a cricket ball. So we are talking about the volume of the shape which is similar to the shape that we have of football or a cricket ball. So the volume of that sphere is given by 4/3 pi r cube. Again, what is r here? R is the radius of the sphere that you have. Clear? And what is volume of hemisphere? We all know that hemisphere is actually half of sphere. Hemisphere is a combination of two words actually. Hemi plus sphere. Hemi plus sphere. So hemisphere means half sphere. Okay, half sphere. And since we are taking half of the sphere, then it is very clear to us the volume is also going to become half, right? So the volume of a sphere you have is 4/3 pi r cube. And if you have to calculate the volume of hemisphere, it is going to be half of that. That means the volume of hemisphere is going to become 2/3 pi r cube. And that's exactly what has been written here. And here as well, r is what? R is the radius of hemisphere that is under consideration. Understood? So I request you guys to please note it before we learn the application of this concept in the problem. Please note it and ask me in case you have any query in this. And this is a very important point which is written here if you pay attention. What does it say? It says two-dimensional doesn't have any volume but area only. Yeah, it should be very important point which like students generally get confused. They ask me, I have seen kids, they asking me like, what is the volume of rectangle, or what's the volume of rhombus, or what's the volume of square? Remember guys, whenever we are talking about volume, we are talking about three-dimensional object. We are not talking about two-dimensional object. Two-dimensional objects have area. but three-dimensional objects have volume. So that should be very, very clear to you all. Okay. Done. All right. So again, this is a very important problem. Okay. You will come across problem like this again in your 10th standard. Let me tell you that here as well. It says Rachel, an engineering student, was asked to make a model shaped like a cylinder. So this portion is cylinder. Okay. This portion is cylinder. Okay. With two cones attached to its two ends. So this is the conical portion that you have. This is first conical portion and that is the second conical portion. By using a thin aluminum sheet, the diameter of the model is 3 centimeter. That's very clear because diameter is 3 centimeter. Therefore, the radius is 1.5 centimeter. That is mentioned here. And its length is 12 centimeters. So 12 centimeter is the length of this entire model. That should be very, very clear to you. It is not the length of only cylindrical portion or the conical portion. 12 centimeter is the length of entire model. If each cone has a height of 2 centimeter, find the volume of air contained in the model that Russell made, assuming the outer and the inner dimensions of the model to be nearly same. All right. So indirectly, what they are asking you, please tell us what will be the volume of this model that Russell has prepared. Okay. Now this model is actually a combination of the different figures, you can say, right? So check out. Okay. So volume of model that you have, volume of model. So that volume of model will be equal to what? That will be equal to volume of cylinder that you have, correct? Because this model is actually a combination of cylinder and two cones that we have, one cone at the top and one cone at the bottom. So volume of cylinder plus volume of two cones. Volume of two cones attached at top and bottom. Okay. Now the best part is both the cones that you have, they have got the same height. You can see both of them have 2 centimeter as their height, and also both of them have same radii. And because both of them have same height and same radii, so their volume is also going to be same. So what is the volume of cylinder? The formula for the volume of cylinder, that is pi r square h. Okay, where r is the radius of the cylinder and h is the height of cylinder. And if you talk about the volume of cone, that is 1/3 pi r square h. But here h will be different. Like here we are talking about the height of the cone. So we have two cones, so that will be 2 into 1/3 pi r square h1. Okay, because the radius is same for both the figures that we have. Like the radius is same for cone, for the cylinder and this cone. That's why I have taken r to be same for both. But if you talk about the height of cylinder is equal to 8 centimeters. So I have denoted it by h, and the height of the cone is equal to h1. Like it is equal to 2 centimeters. So I have denoted by h1. Okay. What you can do is to make things easy for you. What you can do is you can take pi r square common. So if I take pi r square common, inside the bracket, I will be left with h plus 2/3 times of h1. Okay. We all know like what is the value of r, what is the value of h and h1. So now we are going to substitute. R is 1.5 and 1.5 is same as 3/2. So you are going to get 22/7 into 3/2 square. Okay. Inside the bracket, what do we have? We have h, and h represent the height of cylinder. So that is 8 centimeter. So here you have 8 plus what do we have? We have 2/3 times of h1, where h1 represents the height of cone. So you will have 2/3 times of 2. You will have 2/3 times of 2. Clear? If you simplify it, what will you get? You will get 22/7. And here you will be getting 9/4. Inside the bracket, you will be getting, after taking LCM, this will be 24 plus 4/3. Clear? So this 4 you can cancel by 2 times, and this will cancel, 2 will cancel 22 again 11 times. This 3 will cancel this 9 3 times. So what do you have in the numerator? In the numerator you have 11 into 3, that is 33. Clear? Divided by 7 into 2, that is 14. Clear? And here you have 24 plus 4. We all know what is 24 plus 4, that is 28. So this 28 will get cancelled 2 times. So you have 33 into 2. Clear? And what is 33 into 2? 33 into 2, that is equal to 66. That is equal to 66. Now, what was the unit? The unit provided to us for centimeter. Therefore, the volume is going to be 66 centimeter cube. Is that clear? So let us quickly revisit what we did here. In this problem, we were asked to find out the volume of the model that has been prepared by Rachel. And this model, if you see very carefully, it is a combination of the different figures. One of the figure is cylinder, and this cylinder has 2 cones attached to its end. We know the formula for the volume of cylinder. We also know the formula for the volume of cones. So what we did is we calculated the volume of cylinder, which is given by pi r square h. R is the radius of the cylinder, h is the height of cylinder, which is 8 centimeter. And since both the cones have got same height, they have got same radius. So what we did is we calculated the volume of one of the cone, multiplied it by 2, and thereafter we got the volume of both the cones. So you can take pi r square common. So I took pi r square common, and after that inside the bracket we are left with h plus 2 by 3 times of h1. We know what is r. R is, because diameter is 3 centimeter, therefore r is 3 by 2. So we substituted here 22 by 7 into 3 by 2 square. And what is the height of cylinder? That is 8 centimeter. We substituted it here. What is the height of cone? That is 2 centimeter. We substituted it here. Clear? So after that is it's mainly like a solving part, or you just simplify it, and if you do it properly, you will easily get the answer. Hope this problem is very much clear to all of you. Please go through it and ask me in case you have any query in this, guys. Done? All right. So here this solution has been given for your reference. Let me explain this as well to you. Here the diameter is given 3 by 3 centimeter. Therefore, the radius will be 3 by 2 centimeter. Total height, that is the height of the model, was 12 centimeter. Height of cone is 2 centimeter. We were already provided that in the problem. Therefore, height of both the cones will be 2 into 2, that is 4. So the height of the cylinder is going to be 8 centimeter. Okay. And you know the volume of cylinder is given by pi r square h. So they use that formula. And if you talk about the volume of both the conical part that you have, that will be twice of volume of one conical part. So volume of whole model will be, that will be the combination of volume of cylinder plus 2 by 3 times the volume of both the cones. Okay, 2 by 3 times pi r square h means that we are representing the volume of both the cones. They have taken pi r square h. After that, what they did is they substituted the different values here, and thereafter you just need to simplify it. If your simplification and the calculation part is correct, you will certainly get the answer to this problem. So this is for your reference. This is exactly the way you have to represent this particular problem in case you come across this type of problem in your school examination. Understood? All right. So now what do we have? We have one more problem. Let us see. It says find the capacity. That means we have to calculate its volume. Okay. Of hemispherical vessel if the circumference of the top is 308 centimeter. So let us understand what is it. Let's say this is the hemispherical vessel you have. Understood? And if you talk about top, guys, then this top that you have, that is circular in nature, right or not? This top is circular in nature. Clear? Let's assume this is the center, and let us assume that R be the radius of the circular top that you have. So if you talk about the circumference of its top, because top is circular in nature, therefore the circumference of its top will be same as the circumference of circle. Okay, so circumference of top, that will be same as circumference of circle. Clear? So we have 2 pi r, okay, because r is the radius that I have assumed of this circular top. So that is equal to 308. So our goal is to calculate r. So r is going to be 308 into 7 upon 2 into 22. Clear? So I think 11 can cancel this two times, and 11 will cancel 308 28 times. Clear? This 2 will cancel this 28 14 times, and this 2 will cancel this 14 7 times. So that means the value of radius is equal to 49 centimeter. Clear? So we have got the radius. Now they ask you the capacity, therefore the volume of hemisphere. What is the formula you have? The volume of hemisphere is given by 2 by 3 pi r cube. Okay, so if you substitute the value, you will get 2 by 3. Pi is 22 by 7, so you will have 22 by 7, and r is 49, so you will have 49 into 49 into 49. Clear? So this 7 will cancel this 49 7 times. Now all you have to do is you have to simplify it. Okay, you have to simplify 2 into 22 into 7 into 49 into 49, and you will get your answer. So you have 30 seconds. Please simplify it and let me know what you are getting, guys. You have to multiply 2 into 22 into 7 into 49 into 49. If you multiply them, you will be getting 739,508 divided by 3. Now this value you need to divide by 3, guys. If you divide it by 3, you will get approximately this value, 246,502.66 centimeter cube. So that is the capacity or the volume of the hemispherical vessel which is under consideration here. Clear? After that, they have given you like the solution for your reference. Circumference of the top is 308 centimeter, which is same as 2 pi r. They calculated r and they got the same value which we got, 49 centimeter. Thereafter, they applied the formula for the volume of hemisphere and they got the value which is same as what we got. Clear? Now here you have 2 problems that you have to do as a homework. So you all are requested to please do these problems as a homework. And in the very next slide, you are also provided the answer of these. So first you have to try these problems yourself. In case you do not get the answer to these problems, you can always get in touch with your expert and he or she will definitely help you out with that. And yeah, so before we wrap up this session, let us quickly discuss what all we covered. We covered the surface area of cone, we covered surface area of sphere, we covered the surface area of hemisphere. We did problems based on them. We covered volume of cone, sphere, hemisphere, problems based on them. And the 2 problems, the first problem and the second problem that we did in today's session are extremely important. Please make sure that you revise them at home. And apart from that, these 2 questions are based on the topics that we covered in today's session. And you all are requested to please first try it yourself before like discussing this with your expert. The answers are on next slide. So that is it from this session. Thank you so much for attending. I will see you all in the next one. Till then, goodbye and take care.